Okay, so suppose that the proportion of red M&Ms in the milk chocolate packet is approximately 13%. And let's just say that a packet of M&Ms typically contains 52 M&Ms. So let's find the following probabilities. So the first subpart of question number 1 is that 7 of the M&Ms are red. Now, this is pretty clearly a binomial distribution problem. So a binomial distribution is basically a discrete random variable that has 3 characteristics: a fixed number of trials, only 2 outcomes, and a constant probability for each observation. So this matches all 3 characteristics. So we can use this formula right here. Now we can determine that in this formula, the number of trials right here would be 52, since there are 52 M&Ms in a typical packet. Now we can see X here is the number of times for a specific outcome. That is the number right here. So that will vary depending on the problem. P is the probability of success. Now the definition of success we have here is getting a red M&M. So 13%. So P would be 0.13, 13%. Now Q is the probability of failure, and Q and P must add up to 1, so we can see Q is 0.87. And N minus X, well, it's just N, which is 52 minus whatever number we have here. So pretty straightforward. Now we can just apply the formula. So we can write down the formula for our first problem right here, that 7 of the M&Ms are red. The formula would be 52, choose 7. 7 is the X here, the number of successes, times multiplied by 0.13, the chance of success, to the power of 7, multiplied that by 0.87, which is just 1 minus P, raised to the power of whatever 52 minus 7 is. So this is N minus X, and N here is 52 and X here is 7. So 52 minus 7 would be 45. And we can just punch that into the calculator right here. Decimals is pretty easy to use. And we get the answer to be approximately 0.159. And we can just convert that into a percentage. So we can say that's approximately equal to 15.94%. So that will be the percentage of getting 7 red M&Ms. And we know the number makes sense because if we do some quick math here, 13% of 52 is 6.76. So that's like the average number of M&Ms, red M&Ms you'll get in a single bag. So yeah, 15.9%, that's almost 16%. That's a pretty high number. So the answer makes sense. Now, 15 of the M&Ms are red. And for part B, it's basically the same concept as part A, except for just changing up some numbers. So we're still a 52 pack of M&Ms, but we are now choosing 15 because we want 15 of the M&Ms to be red. Again, 0.13, that's the chance of success, the chance of getting red M&Ms. To now the 15th power, because that's how we're trying to find here. And of course, 0.87, that's the chance of failure, we shall call it, and failure by this definition is not getting a red M&M. And this time is to the 37th power because 15 plus 37 is 52. So we just have to punch that into the calculator here. So and we get this decimal, and if we just move the decimal point right by 2 digits, we get the percentage, which is approximately equal to 0.1327%. That would be your answer to part B. Now, half the M&Ms are red, so that's 52. Choose half. Half of 52 is 26. Times 0.13 to the 26th power times 0.87, and 52 minus 26 is 26. So that will be our equation. We just need to punch that into the calculator. We can just replace some numbers here. And we find the number to be really, really low. If we convert that to a percentage, that is about 1.2 to the 10 to the negative 8th power percent. If we convert that to a decimal, there will be 8 zeros followed by 1, 2. That will be your percentage for this. It is really, really small, which makes sense because the average number of red M&Ms per bag is 6.76, and we are finding probability for half of them being red. So yeah, the number has to be pretty small. So yeah, here 1.2 times 10 to the negative 8th percent, or just 0.000000012%. Now, what would you think if you received a bag with 10 red M&Ms? So that would be 52. Choose 10, obviously, to 0.13 to the 10th. 0.87, 52 minus 10 is 42. I just replace the numbers here. Oops. And we can see the chances of that happening is approximately 6.29%, which isn't that low of a percentage. So if I received a bag with 10 red M&Ms, I would say it wouldn't be that surprising or that unusual, because the probability of that is relatively high, especially compared to the chances of getting like a bag with half of the M&Ms being red. That is a really small percent. So relatively, the chances of you getting a bag with 10 red M&Ms, 6.29%, isn't really that unusual, I would say. So yeah, these are the solutions to this problem. 1A is this, 15.94%. 1B is about 0.115%. 1C is about 1.2 to 10 to the negative 8th percent. And for 2, it wouldn't be that unusual because the probability of that is pretty high. So yeah, thank you for watching. Hopefully this video helped you. Bye.